Hey,
Hi.
how are you?
Mhm. Good, how are you?
Good.
Mhm. All right.
Mhm.
Yeah. All right. So, yeah, it's been a while since we last met.
What's new?
All right. So let's see. I did the all the content diagnostics on Jack Weston. Um, I mean, there's still some shaky things, definitely. Let's see. I'm almost done with the section bank too.
Okay.
I I just have like 50 psych social questions left, and that's it.
Okay.
And then let's see, I took a free full length. It did not go well. It's yeah, I got a 492, which is like even low for what I could achieve.
What? Oh, this is MedLife pulling.
Yeah, yeah,
What?
because I was free.
Mm-hmm. And
Yeah.
let,
Yeah. Yeah.
so, um, let me put this in.
Mhm.
So, tell me what the break.
Okay, yeah. So the breakdown. Oh, gee, hold on. So,
And this was on what date again? It was
uh, the 19th actually. So October 19th.
got it.
All right.
Yep.
So it's 122.
For the CP.
Yeah.
Okay.
123.
Okay.
124
Uh-huh.
and 123.
Got it.
Yeah, these are really low breakdowns.
Uh-huh.
Um, but it's also just, in my opinion, it wasn't a good full length. There was no discretes at all. So like you went for like 58 CP problems that were all passage based.
Uh-huh.
It in bio, it got really exhausting. Like if it's all passages and no discretes. I did not like their cars.
Yeah.
I don't know.
So I know you told me the scores that you had previously, and uh,
Mhm.
let's see. I'm gonna input them because I actually forgot to say that I have like a full length tab in the shared sp
Mhm.
spreadsheet, so
Mhm.
I can fill these in. So it seems like blueprint full length one was a 504,
Mhm.
full length two was a 507,
Mhm.
and then for the AMC full lengths for the I have a couple of these like 504, 503, 500, 500, 503, 503.
Yep.
Is that like in order of sample one, two, three, four, and then
Yeah.
three, one?
Should be. Yep.
So okay, let's see.
And then we got the retakes.
Hmm. Okay, so
Mhm.
put these in, and were you able to do like your blind review? Did you find
Yeah.
that to be helpful?
Yeah, I thought it was pretty helpful.
Okay,
There's still some questions I wanted to go over from it that the explanations were not good,
got it.
and I also couldn't find anything online.
Sure.
And yeah, there's also like stuff from the section bank I wanted to go over as well.
Okay.
Yeah, so I guess we could just spend our section just going over stuff I wanted to, I need help with.
Okay.
Yeah, so I guess I'll start with the full length first.
Okay.
All right, share screen. I think I could do this. All right, cool. Yeah, this is just not a good full. All right, so number five. This one is I did not understand. I don't understand how to do this one.
Um, is this like a passage or
Uh,
one?
It's a passage, like it's basically this like equation. I think just this part, to be honest.
Uh, this is really weirdly formatted because they don't have any subscripts, but
Yeah.
uh,
Yeah, that's also another bad thing about this full length. There's no subscripts. There was a lot of typos like throughout the whole full length as well.
so yeah, let me look at the passage because like it might seem like it's just this part that you need, but that's rarely the
Mhm.
case. So I want to look
Mhm.
at the entire thing.
Okay.
Calcium nitrate, complex fertilizer required for plant growth. Calcium nitrate also has wide application in cement production and hydroponics. This simple salt is a source of two nutrients, calcium and nitrogen. Calcium nitrate um, is commonly produced using the ODA process. The multi-step process involves acidifying phosphate rock with nitric acid to produce a mixture of phosphoric acid and calcium nitrate. So, okay, ODA process. In the ODA process, calcium nitrate is formed as a byproduct from the reaction of calcium phosphate hydroxide with concentrated 4 molar nitric acid at 300 C in a sealed isovolumetric container. This produces phosphoric acid and steam as byproduct. So we see this first step here, the
Mhm.
calcium phosphate hydroxide. Do you see where that is? Uh-huh.
Yep.
And then they have the nitric acid here, and
Mhm.
you get the phosphoric acid right there. And
Yep.
you get steam, which is the water,
Yep.
uh, but I guess you also get the calcium nitrate, which is what you're trying to get, right?
Yes.
Okay. So that,
Uh,
yeah.
so this is a like these two are byproducts as stated.
Uh,
Oh, okay.
yeah, yeah. I mean, like a byproduct is just there's no real difference between that and a product. It's just that since they're trying to make calcium nitrate, then
Mm.
the other two would be byproducts. But okay, so we see that. And then
Mhm.
a second step, the mixture is cooled to below. So that first step
Mhm.
was at a high temperature, like three times, the boiling point of water. Um,
Uh-huh.
you also see that it's exothermic, right?
Okay, yeah, I actually have a quick question about this.
Sure.
So if your delta H is negative, it's exothermic. So that means it would be like on the product side.
Yeah,
Oh, okay. This makes
release.
sense. Heat is released.
Mhm.
Yes. Ah, okay.
Yep. So
Okay.
let's see. In the second step, the mixture is cooled to below freezing, where the calcium nitrate, um, which was aqueous, can now crystallize and turn into a solid, I guess,
Mhm.
and can also be separated from the phosphoric acid. So step two, we have
Mhm.
our phosphoric acid from the product
Mhm.
of step one. And we also
Mhm.
have our calcium nitrate, which is
Mhm.
another product of step one. Um,
Mhm.
and then we, I guess, have some water as well that we're adding. And then we
Mhm.
end up with phosphoric acid that
Mhm.
stays aqueous and the calcium nitrate that has crystallized. And
Ah.
so it's a solid, right?
Mhm.
It seems like it's bound to some water,
Mm.
but I guess when they say crystallize, they mean forming a crystal with water because you see that it's attached to water there, right? And I guess
Yeah.
makes sense because they said it's below the freezing point of water.
Oh.
So that's makes sense. Okay. In the third step, the resulting calcium nitrate
Mhm.
is dried. There we go. To remove excess water. So that crystal involves the water, and then the third
Mhm.
step, you dry it to remove the water. And then you produce the nitrogen fertilizer. The filtrate is composed mainly of phosphoric acid with some nitric acid and traces of calcium nitrate. Um, so we have the calcium nitrate. Wait, let's see. Um,
Calcium nitrate. Okay.
okay, so like in between step 2 and 3, they didn't really show it to us explicitly, but
Mhm.
we dried it to remove that water. So you can see that it's just the calcium nitrate, not with
Mhm.
any water.
Okay, makes sense.
And then they said that filtrate, or rather, yeah, the filtrate is composed mainly of phosphoric acid, which is what you have your cursor over there, uh,
Mhm.
with some nitric acid. Uh,
Um, nitric acid.
yeah,
Which one is that?
yeah, I don't see it here. The closest thing I see is perhaps the in the product side, but
Mm.
so um whatever. Okay, so um the filtrate is reacted with oh wait, sorry. The filtrate is composed of the phosphoric acid with some nitric acid and traces of calcium nitrate. And that filtrate is reacted with ammonia. So yeah, we don't see the nitric acid here for some reason, but it's fine. We do still see that we're adding ammonia. Um,
Mhm.
and then it produces a compound fertilizer, calcium hydrogen phosphate over there, ammonium nitrate over there, and ammonium hydrogen phosphate over there.
Mhm.
All right.
Uh-huh. Okay, and it just another thing. Are these don't have charges, right? Or is that just neutral?
Uh,
H3PO4?
yep, yep. Yeah.
Okay.
Is so it's a tripro like phosphoric acid's a triprotic acid.
Oh.
So the first, so it starts with H3PO4, and
Mhm.
when it loses its first proton, it's going to be H2PO4 minus. When it loses its
Mm.
second one, it'll be HPO4 2 minus, and when it loses its last one, it'll be a PO4 3 minus, which is what we see with phosphate, right?
Oh, I see.
Like you should be able to know how to draw phosphate, and it looks like this. So you can see that phosphate is PO4 with three negatives.
Ah, okay.
Yeah. So typically in chemical reactions, you won't see like ions like that. You would see like even something like, like if you have like NaCl or something, like it won't like separate, like, or it will separate, but it's not like it's written in the equation. But okay, so excess calcium nitrate can be decomposed upon heating, so that's at a very high temperature, to release nitrogen dioxide, calcium oxide, and oxygen at an enthalpy of this. Okay, so now, you know, this is something that
Oh.
is not going to be because you were looking at step 3 over there, and
Uh-huh.
most of the time, like not just you, but a lot of times, like when students kind of tell me, like, all right, the answer is here, it's usually not.
Mhm.
So
Mhm.
here, this step three is just the end result of making, the uh whatever um the fertilizer. Uh this is the fertilizer, right?
Mhm.
So that's what the end of step three is. But the question, so what they say after though is that if you have an excess of the calcium nitrate here, um, that it can be decomposed if you heat it, and then it would release uh nitrogen gas, um, calcium oxide, and oxygen.
Oh,
So now we just have to, put in the proper stoichiometric coefficients, right?
oh, okay. So I think like, oh, maybe I was just rushed or I don't know, just not looking in the right part. So which is why,
Yeah. So
because like,
be very careful about thinking that the answer or something is just in some specific local uh region. Also, when you're reading the passages, like you want to have that holistic understanding of it instead of
Mhm.
it just being a bunch of disparate things.
Mhm.
So if we go up to the top again, I can show you, like, I can kind of reiterate what I mean by that. So, like, they're telling us in the first paragraph that calcium nitrate is important and you
Mhm.
can make it using the OTA process.
Okay.
That's it. Um, and then we have OTA process, and then they're telling us what's happening, using words, and that
Mhm.
aligns with what we see here in step one, right?
Uh-huh.
And then they
Oh.
Yep. And then they tell us what's happening in the second step using
Mhm.
words, right? And then they show us the actual reaction for that step.
Mhm.
And then they say that in the third step, using words, that yes, they dry it out, and then they add this, and that, and then they make the fertilizer, which is calcium hydrogen phosphate, and that's what you get in step three. So
Mm.
that stuff is talking about that stuff, right? But
Oh.
after step three, they start talking about how you can decompose calcium nitrate, right?
Mhm.
So we don't see any chemical reaction given for that, right? So we have to take it upon ourselves to write that out, which isn't too bad because they tell us literally, what it
Mhm.
turns into. So you
Yep.
pretty much, your calcium nitrate turning into the nitrogen dioxide, the calcium oxide, and then the oxygen.
Mhm.
So now we just so this isn't given to us as an actual formula, um, but they did tell us using words,
Mhm.
how to set it up, and now we just have to put the proper, you know, um, coefficients.
Mhm.
So
Okay.
yeah,
Mm.
so like for
Yeah. So,
uh-huh.
no, that makes sense. Oh, yeah. So I basically missed passage information. This is something that could easily be answered if I read the passage more closely.
Yeah, so tell me, like, how we can now solve for the coefficients.
All right. So try to balance the least complicated thing first, which, yeah, so it's usually C or H, but we don't have that. So we could try to balance the nitrogens.
Well, we do have calcium on both sides, but
Hmm.
yeah, I would start off, and there's one calcium on both sides, so that seems to be fine. I mean, it's probably not going to be, but then we
Hmm.
see that there's one nitrogen on the right. How
Hmm.
many nitrogens on the left, though?
Let's see. There's one here. There's two on the left.
Good. So now let's put a 2 here.
Hmm.
So now we have 2 on the left, 2 on the right. But now, okay, now how many oxygens do we have on the left?
Let's see. We have six on the left.
Good. So now this could be a little tricky because we have 2 oxygens here, we have 1 oxygen here, and then we have 2 here.
Mm-hmm.
And and then with this 2 in front of the NO2, we now have 4 oxygens here, 1
Hmm.
here, and 2 here,
Hmm.
right?
Yep.
So
So,
that actually 4 plus, oh, you know what?
yeah, I
It
think
might be like
one. Mm-hmm.
that, perhaps.
Mm.
Um, but yeah, so okay, 6 oxygens on the left, and then on the right we have 4 here, we have 5, and then we have 6 here, and
Mm.
yeah, that's kind of it, I believe.
Mm. Or could you like put a two in front of the CAO and then you just put a two on the left side
Uh,
just to rid of the odd number?
if we put a 2 on the left side, we're then gonna have 4 nitrogens.
Hmm.
So
Oh.
let's see what we can do with this one because it might be just something where we round. So let's look at that question. And you see, okay, so you see how this question stem is saying, considering the decomposition of excess calcium nitrate, you can look through the passage. It only says that here.
Hmm.
Uh,
Oh.
L is decomposed, right? So that's so the question is asking about that.
Mm.
So, okay, now, well, I mean, I guess technically we have 2.5, and my guess would be like to either round it to be a 3, but since that isn't a choice, I can perhaps just round down then to be a 2 perhaps, um but I could see how that doesn't exactly line up. So if I did do something with a 2 on the calcium on the left, then maybe that could work, but let me see what what they said it was. Okay, they used it.
Oh.
Um, okay, they did it a little different. Wait, let me see here. Um, Calcium nitrate yields 2 of these, 4 of these, and 1 of these. Okay, okay. So, all right, so let's do like the thing where we, yeah. So let's try that. So okay, let's, put a 2 here. And now we have 2 calciums, right? So on this one, I'm going to put a 2 there as well. So we have 2 calciums on the left, 2 calciums on the right. Now on the left, we have um, 4 nitrogens, right?
Hmm.
And that means that we need this to be F4 for the NO2, right?
Hmm. Yeah.
On the left, we have 6 times 2, we have 12 oxygens.
Hmm.
On the right, we have 4 times 2, 8 oxygens plus 2 oxygens here, 10. And then this is just going to be 1,
Hmm.
and that's 2 oxygens.
Ah, okay.
But now, ah, so now I could have fallen into the mistake of choosing 2 plus 4, which is 6, plus 2, which is 8, plus 1,
Mhm.
which
Nine.
is 2 plus 4, 8, 9. I mean, yeah,
Hmm.
if they wanted to, if they could have tricked us by having an answer choice that said 9.
Hmm.
right? Because
Mhm.
what's the like the tricky thing about the way this is worded?
Um, it's asking about the sum of the coefficients. So like you think you would have to add them all, like add all the coefficients.
But yeah,
This reactants.
yeah, perfect, perfect. So okay, yeah. So for the key takeaway here, the question stem is saying, I mean, like, you don't have to necessarily do CP sections like where you read the passage first. Like if you're on a time crunch, sure you can do you go by the questions first. But even if you do that, you see that they're talking about decomposition of excess calcium nitrate, and the only place where they talk about that is all the way at the end of this passage.
Mhm. True.
Yep.
Okay. So yeah, and I honestly, I'm kind of weak at reading these types of passages where they give you a bunch of reactions. So
Yeah,
I think that was helpful going through it.
yeah. So for this, they gave us like verbal kind of instructions on what these chemical reactions look like. And, as we read through it, we were just like mapping what we read to the things that we're looking at. Um,
Mhm.
so, but, uh, but yeah, when you did this, what were you thinking?
Oh, I think I did something really dumb, and I think I just try to sum all of the reactants here because I was thinking of like the
Well,
spectator ion stuff.
it's still going to be like higher, isn't it? Because up here right away, this is 11.
Yep, that's why. So I wasn't really getting what I wanted.
What did you end up choosing?
I just think, see, I think I just chose something random, then moved on.
Let me see what C was down. If you go down, C, 6. Okay.
Because, yeah.
So, all right.
I,
So
all
now,
right. Yep. All right. So let's see. Now, question nine. What did I have? Oh, this one. I think I ha I don't know how to count the sigma bonds, because I understand the number of pi bonds, but it is kind of difficult to count how many sigma bonds there are.
um, so I'm gonna look at the passage. So let me take a look.
Mhm.
It's kind of annoying that they're not letting you view it like separately, um,
Mm.
format, but okay. Chlor E. Um, so wait, do you read the questions first for CP or the passage? Like, what do you?
Okay, I had a tutor who told me to read the questions first, and I usually do that, but I end up reading the passage anyways.
Yeah. So, I would say that for the entire test,
Mhm.
one of the main things that people like even other tutors like get wrong, at least what I think, is that they they want to kind of like skip steps in a
Mhm.
way, or like, like I'm always very skeptical of like skipping something or using some trick or something like that, just because I think that ultimately it's best to like all right, so let's look at the alternative would be like, okay, I'm reading the question and I'm looking through the passage for things
Mhm.
relevant to that question.
Mhm.
I may choose my answer, and then for the next question, I read it, and then I look again at the passage for things related to that. You end
Mhm.
up going back to the passage for each question.
Mhm.
Um, you end up reading it like I don't want to say anyway. You end up reading it.
Multiple times.
you end up reading it anyway, but
Mhm.
it ends up taking longer um because you're doing it repeatedly, and also since you're only looking for specific things, you
Mhm.
don't have a holistic understanding of the passage, and
Mhm.
that's just not going to help. So like, and you saw that right away with the first question. You're kind of showing me like this is where the answer would be, but I know that that's usually not the case. So that being said,
Mhm.
um CP, if you're truly running out of time, CP is
Mhm.
the only section where you can kind of get away with reading the questions first, because CP passages are usually not that dense or doesn't have much complex data to interpret. But
Mhm.
by that same token, that should mean that it shouldn't take long to read it, right?
Mhm.
So
Um,
that, yeah,
yeah, I think like my issue with timing in CP is the calculations. Like, I don't think I've noticed a trend. Like, I take like 3 minutes or
yeah,
so on a calculation. It's just,
yeah, yes. That's so I'm glad you're telling me that, because that's something that we're going to work on. I can show you a lot of really good, uh, you know, I, I just said I don't like tricks, but like I could show you some good tricks for that. But yeah, I would say that, um, okay. So cool. So, let's see. Also, when you're reading the passage, there's something called that I call like buzzwords, which are like words or concepts or things that they'll likely ask you questions on.
Mhm.
Okay. And you'll get to the point where ideally you'll be able to like see, like look at all that and kind of predict the questions that they can ask you. But yeah, let's use this as an opportunity to also learn how to read the passages. So, okay, it says chloramine T, also known as cat, is used as a reagent in the synthesis of pyrazole. It's an inexpensive, low toxicity, and mildly oxidizing agent. Um, so right away, what is like a buzzword kind of here?
Oxidizing agent.
Yep. Because we don't care. Like these are always so science. This so the science passages are always from like published papers from like PhDs and stuff. We're not expected to know all that stuff. We're expected to know just the stuff we're expected to know. So inexpensive, low toxicity, we don't care about. But okay, oxidizing agent, that's important. Um, And also, like, there's a generalized oxid, like biochem redox pathway in the shared. I shared the Google Drive with you.
Mhm.
In
Yeah.
the PDFs folder, there's a generic kind of thing for like oxidation that shows you like the functional groups and how they change. But
Mhm.
okay, so let's see. And it acts as a source of nitrogen anions and electrophilic cations. Okay. It undergoes degradation upon long-term exposure to the atmosphere, so care must be taken for its storage. All right. So now we have a picture of pyrazole. And what can you tell me about that?
All right. So pear is also it's cyclic. I think it's aromatic.
Okay.
Uh, but yeah. Hold on. Yeah, it has a bunch of nitrogens in the ring.
So
So,
we could call this a heterocyclic ring because it's composed of, different things, not just carbon. Uh,
mhm.
And
Well,
you think it'll have any particular um properties?
it does have lone pairs with this nitrogen. So it might act as nucleophiles, or might want to share those electrons.
It could it could
There's
it could conceivably do that, um
resonance.
but there's also the fact that it can both donate and accept hydrogen bonds.
Oh, oh, because of the nitrogen group.
Yeah, so the nitrogen on its own over there can,
Mm-hmm.
can accept hydrogen bonds, and the nitrogen attached to the hydrogen can donate hydrogen bonds, right?
Oh.
So it can be very likely to see like an NH
Mhm.
to see hydrogen bond like here and here, right?
Oh.
So so this is likely something that can form dimers.
Mhm.
You know,
Oh, oh. And then what would the dimer do
so do you know what I mean by dimer? Just like
to like two
oh,
groups
yeah, two.
bonded together?
Yep. So that's so like yeah, you're gonna also whenever they give you like structures,
Mhm.
you want to identify functional groups. Of course, that's the first thing. And then you also want to think about, okay, like what, how can this, like, what is this molecule going to likely um do? Like, what properties does it have that enable it to do certain things that make it special, right?
Mhm.
So for fawn.
Yeah, those are like the ones that could hydrogen bond.
Mhm. Yep. So yeah, that should also when you see N and NH and stuff like that, you should also be thinking of hydrogen
Mhm.
bonds. So okay, cool. Now cat, this thing on the right, they said is a
Mhm.
reagent in the synthesis of the pyrazole.
Mhm.
Now, what can you tell me about cat, like its structure?
All right. Cat. Okay, there's a phenyl group.
Mhm.
Um, this looks familiar. It looks like to oscillate, I think, like the thing that you make alcohol to be more reactive. That's what it looks like. So it's probably nucleophilic.
Um, the which part of it?
And this one, like, I mean, this group looks like whatever, like the reagent that you would make to like, I think make an alcohol more reactive or something.
Oh, to make it a good leaving group.
Yeah.
The
Or
yep, the sulfonyl group.
yeah, that's kind of what it looks like here, but
Hmm.
um,
So, so so they describe it as it possibly being a source of nitrogen anions, and we see a nitrogen anion there, right?
mhm.
And electrophilic cations. Okay, cool. So
Mm,
see that. Let's continue.
uh, so the electrophilic cation, that's the Na plus, or is that something else?
Um, yeah, I'm not sure. I'm not sure. My thought
Um,
either the nitrogen anion
mhm.
can do what it does, but maybe if it gets removed, then the sulfonyl group will be positive. Like, yeah, I'm not sure. I'm not sure. Because it could be as simple as just sodium, but yeah, I'm not sure. So, but yeah,
Alright.
let's just saying. Okay, cat is prepared by oxidation of toluene sulfonamide. Oh, that looks exactly, yeah, okay. With compound X yielding compound Y as a byproduct. And compound X is produced in situ from sodium hydroxide and chlorine. Okay, so this is a couple of kind of like nested things. So, for instance, okay, so we have this over here, and we're trying to make cat, and we add an uh we add compound X to it, which we can figure out by if we do a reaction between these.
Hmm.
But also, we know that it's an oxidation, so that can also just help. But but okay. If we had, oh wait, sorry, yielding compound Y is a byproduct.
Hmm.
Okay. So what can happen with sodium hydroxide and chlorine?
Sodium hydroxide and chlorine.
Mhm.
Um, can you NaOH Could you make NaCl instead? Or oh no, HCl. Sorry. Oh no. Oh gee. Sodium hydroxide. I mean, you'll get something basic, I think.
So
Uh,
the sodium hydroxide is important.
mhm. 'Cause it's nucleophilic. It'll do a nucleophilic attack, or it'll take a hydrogen
Okay, so you
away.
brought up a good thing. Um, so like whenever we talk about acids and bases, we use the Bronsted-Lowry definition,
Yes.
which is an acid donates a proton, a base accepts a proton. But if we're
Mhm.
dealing with nucleophiles and electrophiles, like in organic chemistry, then we're using Lewis base as the nucleophile and Lewis acid as the electrophile because a Lewis base donates a lone pair of electrons, right?
Mhm.
Now,
Okay.
if you had some alcohol like ROH,
Mhm.
that it has a lone pair that it can, I mean, it has two lone pairs that it can donate to act as a nucleophile, right? But now for the sodium hydroxide, which is just OH minus,
Mhm.
it's gonna be, I mean, sure, it can behave as a nucleophile, but it's gonna also behave as a strong base.
Mhm.
And so that must mean what?
So if it behaves, hmm, wait, so if it behaves as a strong base, then it'll accept the electrons. So it'll take a hydrogen.
Uh-huh. So
Mm.
on this molecule on the left, what do you think it'll take?
It'll take it probably from nitrogen.
Yep. So let's say now we just have one
Hmm.
in here. This is going to have a negative charge, right? And now if we have chlorine, it can take a chlorine and
Mm.
part, right?
Oh, I see.
And then this would be the what is it called? The oh yeah, the chlorine over here.
Mhm.
Um and I think the one of the H's is going to be um perhaps well actually
Mm. But,
I think the so this makes it so that we have chlorine minus, and I think that's gonna abstract this last um
oh,
proton,
oh yeah.
and that's how we get this,
Okay, I see.
right? So
Yep.
so for this one,
Mhm.
they're giving us the reactant on the left, and then they're giving us the product of cat on the right. And we see that, okay, how's it different, right? Well, we must what must we do to go from, this to this? Well, we need to get rid of two hydrogens. I'm just writing like
Mhm.
minus two hydrogens, and we
Mhm.
want to add a chlorine.
Mm-hmm.
right? And then we ask ourselves, and then also like when they tell us that compound X is produced from the mixture of sodium hydroxide and chlorine, we want to think, okay, the sodium hydroxide, so we're trying to remove hydrogens. So a base would help us do that.
Mm.
So
Yes.
that's why they're giving us a base, and that satisfies this part. And then we have a chlorine, which comes from the chlorine, so that satisfies that part.
Okay.
So yep. So okay, that's what you can get. And I guess compound Y is gonna be um
The HCl?
yeah, I'm not sure if it'll be eight well, I mean it could be something as I mean, I don't know if it's gonna be important or not, because it
Mhm.
could be NaCl also. I mean, it could be a couple of things. So I'm just gonna leave it for now. If they ask us about it, which they might, because they called it compound Y, so they might ask us about it. But if they do, then we'll handle it then.
Mhm.
But right now, it should make sense how we go from the toluene sulfonamide to the cat, right?
Mhm. Yep.
Good.
All right. Makes sense. And then yeah, this one so long reaction scheme.
So cat is used in the synthesis of pyrazole rings, um, illustrated in scheme one. So compound one, we have, I guess the AR means the aromatic ring, or
Um
oh
yeah,
wait,
I think it is.
they're just saying that they don't give the oh it's so okay, it's just um like a stand-in for something that could be
Mhm.
something different. But okay,
Okay.
let's look at the scheme again um and actually let's see if we could zoom out a bit because I want to see if we can fit in the text about it.
Um
Yep.
so
And you can just go down slightly. Yeah, perfect. A little bit down more.
okay.
Perfect. All right. So compound one, compound two.
Mhm.
I mean, like, even if we didn't have this, like, we can talk about what would happen. Um,
Mhm.
but so okay, let's see. Step one involves a reaction of compound one and compound two in a
Mhm.
condensation reaction. What's a condensation reaction?
So that's when you form a new CC bond between two molecules. Like I think it's you, yeah, you remove the alpha hydrogen from one and then you form a new CC bond there. Or
Well,
in
condensation reaction is just another word for dehydration synthesis, right?
uh,
And that doesn't always have like, so I'll give you an example. So these are two amino acids,
mhm.
and the R group I'm just writing as R.
Oh,
If you see this,
uh-huh.
that forms H2O. So H2O leaves, and then we
Mhm.
have our um
Mm. Yeah, the peptide bond. I think I was thinking of like that really specific mechanism in organic chemistry. The dials ether? No, I don't forget still.
so this this in orange is the bond that we made, right?
Ah.
So it doesn't have to be always with carbon.
Mhm.
Actually, in most cases, it won't be carbon actually, because
Mhm.
because so you need to remove an OH from something and an H from another thing to make the water that leaves,
Mhm.
right? And that's why it's called dehydration, because water leaves. And
Mhm.
then synthesis means you're combining things to make something, right?
Mm.
What's
Okay.
the opposite? What would the opposite be?
Dehydration? Oh wait. Um, so condensation is when water leaves.
Yeah, so think about it as dehydration synthesis. So
Hmm.
if you just take those
Um,
words and make it the opposite, what's the opposite of dehydration?
I no
Yeah.
hydration reaction.
So there's going to be a hydro part, but now, and then what's the opposite of synthesis?
Um, what- the one lysis.
Exactly, right? And that's when you have water added, right? Um, to break a bond.
Mm-hmm.
Okay. So
Mm, okay.
yeah. So you'll see that a lot, especially yeah, you'll just see it all the time. So okay. So we have a condensation reaction, and that makes sense because we start off with two separate things and we end up with one thing
Mhm.
that's attached, right?
Mm, yeah, I think like the double bond's tripping me up.
Oh, okay. So let's see what can happen here. So if we look at the reagent, what can that tell you? Like for instance, this one.
This one, it looks, yeah, uh, yeah, it looks like this one's a little electrophilic because of the negative oxygen.
Do you know like if you were to draw it?
Uh, I think is that like a carboxylic acid without its H group?
Yep. It's just that, right? So, okay. So now this um can cause something to happen here, and it seems like what's happening is that the oh wait, the H, okay, so this oxygen
Mhm.
leaves and
Hmm.
uh
Oh, why it leaving?
so I mean like because we see it here and we don't see it there, right? But also in a dehydration synthesis, oxygen is part of the H2O that leaves, right?
Hmm,
So now
true.
we just need two H's that go. What about
Mhm. Oh, so those are the H's that leave.
yep. So now the bond can be made directly from this carbon to
Hmm.
this nitrogen, right?
Hmm.
And so that's what happens, and you get this here. So you get
Hmm.
orange. So like this carbon
Hmm.
is right there, right?
Hmm. Oh, okay, yeah.
Right? This hydrogen is this.
Hmm.
This AR, and it's
Fine.
light, but it's like a prime. Yeah,
Hmm.
that's AR prime, right?
Hmm.
And let me use light green for the other one. So like now this nitrogen is going to be a nitrogen that is it going to be this one or this one?
Where which this nitrogen? That one should be this one over here. Yeah, it should be this one
Yeah, tell me why.
because this one is attached to AR and that's
Perfect.
like right
Perfect.
here.
So yep, that's this one. Good.
Mhm.
Awesome, awesome. So okay, that makes
Uh,
sense, right? Uh
then what? about this guy?
Uh-huh.
And just ignore him?
Oh, I think that's just gonna be like the alcohol that can kind of maybe take care of the uh byproducts, perhaps, something like that. I mean, I
Uh,
there's also like an HCl here. Like I don't even know what that's doing there. Like
oh.
that's kind of I don't know. But I don't know how that makes sense. But okay. So we get compound three, and let's see. Step one, condensation reaction in ethyl alcohol and presence of sodium acetate. So this is the sodium acetate. This is the ethyl alcohol. The resulting product, compound three, is treated with CAT, which, that's what we saw previously, and glacial ethanoic acid. So I don't know what the significance of glacial means, perhaps cold temperature, but who knows? Uh, ethanoic acid in step two, yielding compound four. So compound four is here. And let's see what changes. Well, it seems like,
Hmm.
yeah, what do you think uh,
Ye-
changed?
seems like if wait, hold on. Oh, so that's cat. Okay. Interesting.
I just mean like what changes from compound three to compound four?
There's a triple bond now.
Yep,
Yeah. And then the hydrogens are gone as well.
yep. So we lose these hydrogens. I mean, when this one's lost, this can just come in on itself to be the triple bond.
Mhm.
That's accounted for. And this one is lost, and that's why this one has a positive, or sorry, this one has a negative charge here,
Mhm.
because it's lost the hydrogen, right?
Mhm.
So this just goes back on itself like that.
Mhm.
The nitrogen is positive because one, two, three, four, it has four bonds and it normally has five valence electrons, so it lost one. So
Mhm.
it's positive. So okay, that's what we have. So yeah, with these types of things, like you want to like fundamentally ask, like, okay, this is before and then this is after, so then what could have happened, right?
Mhm.
So
Yeah.
we get our compound four, and then they say compound four is further reacted in step three with compound five, which they're giving us here. And
Mhm.
what functional groups do you see here?
Compound five. All right. So that's ester right here.
Okay.
Yeah, and then we just have a alcohol, a hydroxy group. We also have an alkene here.
Um, mm-hmm. And
Mhm.
this is something that we kind of see uh in biochem. Like, have you seen this, something like this before?
A CoA?
Oh, just a hydroxy ester, but we typically see it without the double bond.
Mhm.
But okay, cool. So good. And then when we react these together, they yield the basic pyrazole ring, compound six, which is what we have here. Now we look at what came before. We could see, okay, so AR prime, I mean, and then it goes back to the double bonded nitrogen AR, so that's accounted for. And then for compound five, it seems like, well, the OH group
Mhm.
leaves, right? This thing.
Mhm.
So I think what happens here is that, let's see. Yeah, I think something may
Mhm.
eliminate that. And then this could be maybe like a negative charge that can then attach to, or maybe it could even be like, well, if it leaves, I mean, okay, it's gonna add to this one at least, right?
Mm,
So I'm thinking
yeah.
either like because there's no other reactants it seems, but like either the let's see, one, two, three. Yeah. So I mean, something happens with this thing being lost and then this attaching over here, right?
Okay, so that's the double bond. Like this double bond kind of goes over here. Okay.
Yep.
Hmm.
Okay, then let's see. Compound, this function and subsequent chemical properties are heavily defined by the identity of the AR and AR prime groups used in synthesis of the uh Kurzel rings. So, okay. So like that whatever the identity is matters. And I'm gonna guess they're gonna maybe give us examples of like stuff with steric hindrance, stuff
Hmm.
without. So let's look below. Oh,
So less
I was asking about
oxidation.
sigma bonds. Now I remember. Um, okay. Consider the identity of AR and AR prime to be phenyl groups. What would be the predicted distribution of sigma and pi bonds in compound three? Okay. Let's go to compound three. All right. So what is a sigma bond?
A sigma bond. Okay, like it's a single bond, and you can only have one of them.
So like describe to me what that looks like.
It should be they're free to rotate. Think they're like kind of horizontal compared to pi bonds, which are side by side.
Yeah, so you could say that they are that they are between the atoms,
Oh.
like the orbital being when the orbitals are between the actual atoms and they
Oh.
overlap like that, that's a sigma.
Hmm.
So this is a sigma bond. And when you have, let's say, a double bond, you're still going to have the sigma,
Hmm.
but you're going to have, let's say, these, and these are not so like the electrons for this the vert like the perhaps like y py orbitals, they're not in between the atoms.
Oh.
So they're like, you know, up and below, but not in between. But there can still be some overlap.
Mhm.
And that's also the reason why as you go from single to double bond and double bond to triple bond, they get shorter. Because if they get
Mhm.
shorter, there could be more overlap of the vertical parts, right?
Oh, I see.
So now this one is still going to have a sigma bond, but now
Hmm.
it'll also have a pi bond.
Hmm.
And then if you have, so okay, this is single bond, this is
Hmm.
double bond, and then for a triple bond, you're still going to have the sigma,
Sigma.
and then you're going to have the py overlap, and then you can have like diagonal on the or the z-axis another
Hmm.
pi bond. So this is going to be one sigma, two pi.
Hmm. Hmm.
Now for compound three, we have sigma, sigma,
Hmm.
sigma, 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 sigma. One, two, three, four, five, six sigma. And then
Hmm.
this one also has a
A
pi.
Mm-hmm.
bond, right?
Yes.
Now, oh, okay. Now we also have to remember that we have benzenes for the A,
Mm-hmm.
right?
Mm-hmm.
Now let's do that for benzene. So we have single bond one, two, three, four, five, six. So that's six sigma. And then one, two, three pi, right? And since we have two of these, we double this.
Mm-hmm.
12 sigma,
Mm-hmm.
6 pi. And then we add this to it, which is, this stuff, not the phenols. And so this is going to be 18 sigma and 7 pi. Um,
Yeah, that makes sense. Let's see. Was that? Hmm.
yeah, seems like
Uh, is that a typo?
um let's take a closer look uh at the compound compound 3. So I think I might be missing one. So one, two, three, four, five, six. One, two, three, four, five, six. And then hmm,
Unk.
let's oh crap.
Mhm.
Uh I forgot the hydrogens.
Oh, wait. So that's also separate sigma bonds?
Yeah, sigma bond is gonna be anything, it's gonna be in any bond, right? A single bond will have just a sigma, a double well, yeah, single bond, double bond, triple bond, they all have a sigma bond in them.
Mm-hmm.
So, so okay, that means we have one, two, three, four,
Oh.
five, six,
Mhm.
12 more. So this, so 18 plus 12, we have, well,
Mm, I think it's
six of these, 12
mm,
off. I mean, like I'm off by like like what, two?
oh, let me
Oh,
check.
I know, I know. So since this is
Mm-hmm.
bound, since this is bound to this molecule,
Mm-hmm.
one of the hydrogens has to leave.
Oh,
So this is five, so it's going to be 10 plus the 18 for 28.
oh, okay. Okay, that makes sense. Yeah. All right, that's a tricky one.
Yeah. It's like, because like the thing is that, we use like the standard notation like this because it saves time and the hydrogens are implied,
Mm-hmm.
but that can also make it uh like easy to forget. But for this problem, at least the choices, like if we go to the choices, like they're all like 27 and blah blah blah. Like if they had B 18
Mm-hmm.
sigma, like that's why like
Mm-hmm.
this test, I don't know, I don't know like the rest of it, but I feel like on a real test they would have given you answer choices that are, because you want the answer choices to have some type of like, because otherwise it'll just be too easy. So you want the wrong answer choices, some of them to still have some valid like logic behind it. So like if you did what I did, like this, right, you would, so I think if they had, let's say B with sigma 18 and pi 7, a large percentage would probably choose that.
Mm-hmm.
So, but yeah, that makes sense, right?
Yeah, makes sense now. Okay, now I know how to figure it out.
Yep. So
Okay.
I do have a student in 8 minutes.
Uh,
So
okay.
I you just signed up for an hour, I believe.
Yeah, fortunately, but
Yeah.
um,
So like, I can put you in for um next time. Do you want me to?
oh, sure, sure. Yeah,
What?
I guess
Yeah.
yeah, because there's definitely some stuff from Section Bank 2 I'd like to review.
Yeah, yeah. And then I'm sure you have more questions from this test too, right?
Hmm.
So
Yeah.
would like let's see. What would like Wednesday maybe?
Um,
Or it could even
hold on.
earlier than that. It could be yeah.
Let me check the work schedule. Uh, Actually, I don't think I have anything on Wednesday for work at the moment. Yeah, no work on Wednesday. Okay. Yeah, I could probably do Wednesday.
Do you want to do Wednesday at 4:30 Eastern?
Yeah, that would work.
And do you want that to be like a longer session?
Sure, sure.
Should I put you in for 2 hours, 90 minutes?
Uh, yeah, 90 minutes would work.
Okay. Oops. All right. And let's see.
But yeah, I'll let you know if something comes up.
Yeah. And so we went a little bit over today, so that's just like 15 minutes, which is just going to be like around like $20. So
Mhm,
yeah, so next time you could just add like
mhm,
20 to the
mhm,
payment.
mhm,
And yeah, so yeah, when we meet on Wednesday, we'll have more time to go over more of this stuff. But do you think, it helped how we went over it?
Yeah, and yeah, it does. And also should I take an FL this weekend? Another one?
Um, I think he took this FL on the early side because I think the
Yeah.
first FL that I have scheduled for you is like November 2nd, like,
Hmm.
you know,
Oh.
um, tomorrow. So,
Hmm.
and that's when you're going to do Altius full length one.
Hmm.
Uh,
Yeah. Oh, I could probably do a blueprint. I haven't purchased any LTS ones because I was just looking at other packages.
oh yeah, I think we chose that just because I think it's free.
Hmm. Oh, I tried to access it. I don't think it's free anymore
Uh,
because it kept giving me an invalid link.
got it, got it. So let's see. Um, okay, I would say that hold off on the test until we meet. Um, well, oh, hold on, let me see. So the blueprint exams, we have you're gonna take all 10, and you've done one and two.
Mhm.
Um, and then there's Jack Weston full lengths. Um,
Mhm.
okay, so let's do this. Let's have you like because you're still reviewing this test, right? Or
No, I finished. There was just, these are lingering questions.
okay, and how far along are you in the section bank?
I just have 50 more psych questions and
Okay.
stuff.
All right, then yeah, I would say yeah, you could take another test.
Mhm. All right.
Yeah. And then
I'm
sorry.
Yeah, I think I could purchase Kaplan ones because it also comes with their Q bank, which I mean, since I
Eh,
kind of use you.
Yeah, I wouldn't recommend Kaplan. They're not that good. Especially if you have to pay for it.
Mhm,
But we already mapped out all the tests that you're going to take.
mhm,
So there's the blueprint ones, of course, and then there's also Jack Weston free ones.
mhm.
Um, so yeah, so I don't think you're going to need to pay for any other tests.
Okay.
But so yeah,
Yeah.
maybe tomorrow take like the one of the Jack Weston ones because they have three free.
Okay.
And
Yep.
yeah, so okay. And then when we meet on Wednesday, we can go over lingering questions from this, from the
Mhm.
section bank, from the and from the test that you will be taking tomorrow.
All right. Sounds good.
All right, awesome then. So I will see you on Wednesday, okay?
Yep. All right. See you then.